Hey guys, guess what? This is our lesson 2 that we're going to rock together. And in lesson 2, we're going to focus on the factors that affect the purity of a substance. Oh yes. So what are the factors that affect purity of substances in general? In fact, I'd like you to note one thing. Exam questions are loaded here to the core. So the factors that affect the purity of substances, right, there are a couple of them. They include number 1, density is a factor that affects the purity of a substance. Number 2 is called freezing point. Number 3 is called melting point. Number 4 is called boiling point. And then number 5 is called refractive index. So there are 5 factors that exam questions revolve around that affect the purity of substances. What are the factors? Number 1 is called density. Density. Freezing point, melting point, your density, your freezing point, your melting point, your boiling point, and your what? Your refractive index. All these 5 factors must be ringing inside of you. And don't forget this very quickly, that as impurities can have significant effect on them. So impurities have significant effects on what? Density. Impurities have significant effect on freezing points, on melting points, on boiling points, on what? Refractive index. Are we ready to look at all of them one by one? Let's start with the first, and that's what? Density. So if you're looking at density, the first thing, right, that is expected of us to know very fast is that the definition of density. You know, density in physics is your mass per unit what? Volume. And the symbol for density is your rho, right? Or we say rho is equals to what? Mass all over what? Volume. That's your density. Please don't forget this, that the density of a pure substance is what? Definite and constant. Listen, the first thing I'll tell you is for pure, then I'll tell you for impure. Your pure substances have definite and constant density, so they are not shaking anywhere, while that of impure substances is higher than what expected. I'd like you to know that. And also very important, for instance, when we say the density of your pure water, what is it? It is 1 gram per cm cube at what? 4 degrees Celsius. That's density of your water, your pure water. Anything higher than that, it is impurity that is causing it. So density of pure substances, they are what? Definite and what? Constant. But for impure substances, higher than expected. Number 2 character is your freezing point. Yes. So how does your freezing point come and interplay, or what does it do? Don't forget this, that the freezing point of a substance is that temperature at which it transitions from your liquid to what? Solid. You carry your normal water, put it inside the fridge, right? It comes to a point where it will freeze. That point is called your what? Your freezing point. Where it will transition from where liquid all the way to solid. And don't forget this, that impurities, what will they do to freezing point? They lower freezing point. Anything that lowers freezing point, what is the cause? Impurity. And that phenomenon is called freezing point depression. There's what is called freezing point depression. What is the major factor that results to depression in freezing point? Impurities, lower freezing points. And don't forget this very fast, that the freezing point of a pure water, what is it? 0 degrees Celsius. And you know that your 0 degrees Celsius is the same thing as your what? Your 273 Kelvin. Whether 273 Kelvin or 0 degrees Celsius, they are the same. That's freezing point. Why water that contains dissolved salt? If there is dissolved salt inside water, that dissolved salt is impurity. And it will make the water to freeze at a temperature that is below 0 degrees Celsius. So instead of your normal pure water to freeze at 0 degrees Celsius, you are now seeing it, you know, for instance now, if you move from all the way from 4 to 3, from 3 to 2, then 0 degrees Celsius, right ahead. From 0, where are you going to? -1 to -2 to -3 to -4. Instead of it to freeze at 0 degrees Celsius, it's now freezing at -4. My brother, what is that? Impurity is the cause. Are you getting it now? Don't forget this very quickly. Number 3 is called melting points. Please, how does melting point affect the purity of substances? Don't forget that. Melting point first is the temperature at which a substance will transition from solid to liquid. From solid, from like ice block, leave it down, it will melt, right, to liquid. That's melting point. So what will impurity do? The melting point of a pure substance is sharp. it is definite and has a short melting point range. Please, your melting point of your pure substances, it is sharp, it is definite. Even if it want to have range, it will only have short melting point range, not a wide range. And don't forget this, that the melting point of your pure sodium chloride, your sodium chloride NaCl, was the melting point, 801 degrees Celsius. Shall you see? Short, like it is just definite and precise, 801. There is nothing like if you say, for example, 801 degrees Celsius to like, let me say 900 degrees Celsius. It's too much, right? That's a range. Impurity is now there. Another thing you should know is this: impurity will lower the melting point of a solid. Listen, past question. Impurity will lower the melting point of a what? Of a solid. So instead of a solid to melt, right, at a specific temperature, the temperature is now lower than the expected. What is that? Impurity. And it will widen its melting point range. What will impurity do? It will lower the melting point of a solid and widen melting point range. Are you getting it now? So now let me ask you a question. Let's say, for example, your sodium chloride is a solid that has a melting point of 801 degrees Celsius. If they give you option A, impurity is now introduced, you are now having between 801 to 900 degrees Celsius. Or option B, you are now having something of like, let me say 801 to, or let me say from 700 to 801 degrees Celsius. You should choose this one that is 700 to 801 degrees Celsius, right? You already know. Because impurity will what? Lower the melting point. For freezing point, impurity will do what? Lower freezing point. Impurity will do what? Lower melting point. Don't forget, right? But for density, impurity will elevate density. It will increase the density. And then the fourth property that you should know is your boiling point. What is the effect of impurities on boiling point? First, your boiling point is the temperature at which a liquid, you know, your normal water, you have to put it on, like apply temperature, apply heat to it, so that you start to what? Boil. The temperature at which a liquid transition to gas, what is it called? Boiling point. Don't forget this, that the boiling point of pure liquid is sharp. Boiling point is sharp. Boiling point is definite with a short boiling point range. So if it must have range, that range must be very short. And don't forget this, that boiling point of pure ethanol, constant question, 78 degrees Celsius. What is the boiling point of pure ethanol? 78 degrees Celsius. While that of pure water is what? 100 degrees Celsius boiling point at atmospheric pressure. Another important thing you must know, impurity will come and raise. Impurity raises. Impurity does what? Raises the boiling point of a pure liquid and widens the boiling range. And that is called your boiling point elevation. Let me rewind. Will impurity increase boiling point or impurity will decrease boiling point? Impurity will increase. To increase means to elevate. In terms of boiling point, you know you are applying temperature, applying heat to something. It's already, you are increasing the temperature, right? Impurity will further elevate the boiling point. Instead of it to boil like your pure alcohol, instead of it to boil at 78 degrees Celsius, it's now boiling at 93 degrees Celsius. That's impurity. Instead of your normal water, 100 degrees Celsius to boil, it's now boiling at 120 degrees Celsius. Please, what is that? Impurity. Because impurity elevates or increase boiling point. But you see, melting and freezing, impurity will what? We decrease or lower their what? We lower their temperature. Are you getting it now? So impurity decreases melting and freezing point, but it elevates or increases your boiling point. What about density? For density, impurity with what? Increase their what? Density. Don't forget this thing. So, and then number 5 is refractive index. Oh yes, what is refractive index? Refractive index measures how light is bent or refracted when entering a material. Let me say this is a material, and then light is now coming in. As light is coming in, let me say there is now what this is your light that is coming in, and then there is now more like a change. Are you getting it now? Instead of the light to continue the movement like this, there is that change in the direction of light as it passes through a material. That is called your what? That's your refraction. And from here now we can get refractive index. So refractive index measures how much light is bent or refracted when it enters a material. And I'd like you to note this, that the presence of impurities can alter the refractive index. So can impurity offer refractive index? Yes, impurities will offer alter your what? Your refractive what? Index. And there are certain things you must know very quickly. Now follow me, let me show you. Among the things you must know very, very fast include the following. Two things. Number one, change in composition can alter what? Refractive index. Why? Because refractive index is dependent on the composition and structure of the substance. As a result, impurities with different refractive indexes will change the overall refractive index of the substance. So now, if there is impurity in any material or substance, what happens? Refractive index is going to change. So change in composition because of impurity, we change the what? Refractive index. That's number one. Number two is called concentration of impurities. You see, at which the concentration of the impurities is lower now, we can say, okay, we can manage a bit. But when the concentration is high, what will happen? It will change the entire refractive index. Don't forget this, that even a small amount of impurities can affect refractive index. Now let's talk about a higher level of impurity. It will alter the entire refractive index of the what? Substance. So your changes in composition and concentration of impurities have effect on your what? Your refractive index. And very quickly, don't forget this, that we looked at 5 factors that affect the purity of substances. What are the 5 factors? Number 1 is density. Number 2 is called freezing point. Number 3 is called melting point. Number 3 is called boiling point. Number 5 is called what? Refractive what? Index. And I'd like you to know this very quickly, that for your pure substances, all these factors that we have mentioned, they must be what? Constant. They must be what? Fixed. They must be what? Precise. They must be at a narrow range or definite what? Range. And these are the factors that affect the purity of your what? Substances. If you get this very quickly with me, guess what? You are very, very much ready to flow into past question. And our past question is our what? Lesson 3. I'll see you in lesson 3. Bye-bye. Enjoy.